Okay, we are recording now. Welcome to the evening of Python coding. This will be the last evening of Python coding for this year, but we will continue next year. We've been doing this for more than 7 years, and hopefully we'll continue longer. I'll introduce Gabriel, who's gonna talk a bit more later, but I met Gabriel through going to a conference in Israel, PyCon Israel. This is how the connection with his company Jito.io got started, and indeed Gabriel is here to give a talk and tell us more about PyLint. I will hope in the future I'll be able to get them to actually show more things about what they're doing. But for now, let's show things with PyLint. So Gabriel, go ahead, share the screen and take it over and tell us about PyLint.
Perfect. Thank you, Jacob. Thank you for inviting me. Thanks for everyone joining. So if you don't hear me well or something, we're kind of far away, just raise your hand and I'll try to do something with the internet behind me. So what is PyLint? I'll not make it like a standard conference with all the nice stories, but you will see some slides from some of the conferences that I already spoke about PyLint. I hope you all can see my screen now. So PyLint is actually one of the libraries, one of the tools to do static code analysis on Python. Now, what is static code analysis? So as you know, I have a quote that I like, that we need to write code that people understand that the machine can inaccidentally execute. Now, that's true that the most important thing that machine will execute our code, but sometimes our code has some stuff that we want to do nicer, right? And because we remember that computers can execute our code, they can also analyze it. And if they can analyze it, we want to take this analysis abilities and build some new feature on our software development lifecycle that based on it. So you must, you all, I'm pretty sure, know some tools for static analysis in Python, like the simple is Flake 8 that enforce the PEP 11, this coding style, which is the most simplest way to use static analysis, right? So we want to make sure all our code look the same. Python is not an easy language. I mean, it's an easy language to write, but when people came with no experience, which happened a lot in Python, because, scientists came to Python, junior developer came to Python, people who wrote, like backend services, and I want to write in web services or just play with data. Many people came to Python and they don't know how to write Python, right? Sorry about that. And we need to enforce somehow the styling code of Python. So this is the most simple use for static analysis. PyLint take it a step further and say it's not only about styling, it's about understanding that our code is behaving right. So before we execute, we can make sure that we don't have bugs in our logic, etc., by testing, by end-to-end testing. But we also want to know that our code base keep themselves clean, keep themselves doing what it needs to do. And this is where PyLint came into the table. So it's not the most simplest way for linting, but it's a simple way to create the layers that you need for creating custom options for static analysis. So PyLint itself has a lot of checkers, built-in checkers, which is like rules for enforcing many Python styling guide and stuff like do not duplicate code, do not have redundant return statement, etc. Today, I'm more going to talk about not only running PyLint. Of course, I'll show all the basic functionality too, but the main thing we're going to talk about today is some custom usage I get into PyLint. And I have two different use cases that I made in the last 5 years in two different projects. So the first one was a very big code base of
Gabriel,
yeah.
before you continue, you're sharing the screen. What would you be seeing? xyz.fuba.io, and then there's a general access morning. Okay, I wasn't sure that. Okay.
Yeah, that's the right one. I mean, I'm just chatting right now, and I didn't want just to put the opening slide. Whatever.
Okay.
Yeah. Okay. So let's
Got it.
continue with this one.
I
So
wasn't
everyone
sure
knew.
whether you're showing the correct screen.
Yeah. So this is actually the second use case. So the first use case, as I mentioned, we have a very big code base of automation tests that written in Python. Now, as you can assume, people that writing code, test code, are not always best in writing code. And this code base became with a lot of finesse. And we do have a lot of external interface that this test used to test. For example, it has some tests that run against web browser. It has some tests that run against switches, firewalls, some network equipment. And a lot of that code, I mean, a big portion of that code became very dirty and very hard to maintain. And when we try to analyze and decide and look at the code to see how can we improve the way our testing code is written, we got the decision to insert custom rules in PyLint. So let's talk about, for example, custom rule. We can see that people who came from the scripting world are repeating many times the same portions of code. So like you do in script, you write script, you ship it everywhere. But one of the basic solid or key principles in writing clean code is about writing code that you write once, you do many, whatever you call it. And that's a very good, very strong principle in Python. So then we write a custom PyLint rules that check people are not duplication long portions of code, but using frameworks that we built, and we can make sure this framework is reliable. This was the first time I made a project with custom checks on PyLint, and of course I'll show demo soon. And the second one is about continuous security. So today, with all that, what we call shifting left, etc., if 10 years ago, 15 years ago, all the cybersecurity vulnerabilities was in configuration, let's say, for example, this port used to be open to the world, or these machines didn't protect it well in firewalls. Today, every vulnerability is considered as part of the code. If you look on vulnerabilities that we have in the last years, so for example, log4shell, text4shell, both of them are very good 0 days vulnerabilities, which was part of code, nothing in configuration. Okay, sorry?
You're fine.
Great. So we got to understanding that we need to make sure one of the pieces of a code review process is about security testing, right? So we can add a lot of static analysis tools for security in our CI/CD pipeline. Okay, so for example, we have security static analysis security tools called Bandit for Python. We have libraries for infrastructure as code as Chekhov and Kix. We have things for secret detection. We even have StemGrep, which is a cross-language static analysis tools. But that's fine. I mean, there is kind of friction between what people see, which is usually do not cover the most critical security issues in code reviews, and what machines see, which is thing that general to the market. If we have something that's specific to our product that people can miss and tools cannot detect, we need to create something in the middle. And then this is where we started to use PyLint. So what we have is actually, we do have in our product a 0 day vulnerability that led us to write a custom check on PyLint. So one of our very senior engineers deliver, we do have functionality, the first slide, we do have functionality, like the copy link, from Google Drive. So this is kind of generating a public link with UUID. one of our guys just replaced the decorator from authorizer custom viewer to authorizer all. And because people, they do the code review, and this one was a very, very senior engineer. No one paid attention for what happened here, and we delivered the code, and we got a real CVE, 0-day CVE to our product that everyone can do anything in one of our endpoints can just found in scanning of the internet. And this is where we decide to start write a new PyLint checks for security checks. So we are analyzing the product, we are creating threat modeling, and then instead of just declare threat modeling in a nice document and share it in the organization, we are actually applying custom PyLint checks into our product that make sure for every code review, for every code push or code commit, we covered for any particular use case we have in our product, security use case. So again, the cases that I created custom PyLint rules, the first one is for organization framework. We want to make sure all the engineers have the highest velocity they can deliver, but keep the organization styling and guidelines, etc. And the second is for creating a custom security rule. I'm pretty sure that many of you now have some thought how they can use static analysis custom check, and we will learn how to do that. In your organization, I'll be happy to hear more about it now or later. Maybe we can even try to create something together that fits more for your needs. If not, that's fine. I have already, and I also shared the demo where I already created a custom check. So now after we talk about the purpose and the pain, let's start to look on the PyLint. So PyLint is actually a library that's maintained by PyQA, which is a very big Python open source organization. Everything is open on PyLint. You can check the docs here. And running PyLint is pretty simple. So how can we run PyLint? So first one, we need to install it, of course, with a pip. We can keep it on a, in our requirement test or something. And also PyLint has a lot of integration with every IDE that we have. So that's very important when we want, to keep the style on the organization. We need to know that people, has a very easy way to use PyLint. And PyLint is, of course, support, as you can see here, many, many IDEs. And if we configured everything well, so let's look how it's looked like here. I have a problem with this authorizer, right? Because all is a very sensitive authorizer. So PyLint will show me, as you can see here, authorizer with all should be used with caution and only from infected code. So this is the second step. Make sure that developers has an easy way to detect what happened in PyLint and implement it in their IDE. The third step, of course, is having it as part of your CI/CD. So first, you can have it as a pre-commit hook. No one can commit stuff to master. There is a very easy configuration how to configure PyLint in a pre-commit hook. I actually prefer running pre-commit tools on Docker images because people sometimes mess with their virtual environment and Python environment. The tutorials here show, for example, pre-commit hook that just has an entry of PyLint with a very simple command. But you can, instead of that, there is many instructions on the internet how to run PyLint in a Python Docker. And then instead of entry PyLint, you can run something like Docker run PyLint. You can, even fetch it from Docker registry, from the public Docker registry. So this is the third step. The first step, which is not much documented here, but there are a lot of internet resources for that, is of course putting it as a part of your CI/CD. It can be a GitHub action, it can be in Circle CI, whatever CI you are using. You can create an action that will run PyLint as part of your commit. The best thing is, of course, fail PRs, which PyLint fail for. Okay, let's run, for example, PyLint in our custom environment. Okay, so I'll open the terminal here and I'll just run PyLint on one of my file. I already have a configuration in VS Code for debug my custom rules, so I'll just show how it's run here. And we can see here that we ran this command, okay? And my code was rated 10 out of 10. So that's mean my code now rated fine. And this rate, you can, of course, in your CI decide, for example, 9.5, it's the one that's good for your CI to run, because you not always want to be rated as 10, because sometimes linters and static analysis can create, can lower the velocity of delivery. As a tech lead, I always try to balance between velocity and quality. So sometimes, depend on your organization, what you do in PyLint, you can decide, for example, that 9 or 9.5 is a nice score for your organization, and fail PR only if it's more than this number. Okay, so now we know that we have PyLint and how we install that. And we also show a bit on how to run PyLint. Okay, we can, again, run it as a CLI. This is the way we're going today. CLI, I'll show later how we can run it also in debug mode and debug the rules that we have. We can also have configuration file for PyLint that's saying, if you can see here in the command that I already ran, we can see that I have some configuration. So I load custom plugins, okay? I disable them all and enable only one of the plugin, which is my decision. You will not want to disable all, but sometimes you say, I don't want particular rule to run because we are not enforcing it in our organization. And this one you will want to put into the PyLint RC and configure this PyLint. This is the very basic usage. You can also, when you analyze the logs, when you're trying to understand why thing happened, or if I should fail a PR because of something, you can, for example, look at the exit code. There is sometimes PyLint has categories. This category is also important for custom check that I'll show soon. And for example, we can say that fatal message issued, we don't want never to get into the main branch, but for example, refactor message issued, we are pushing into some backlog, and we'll back to that later. Okay, so this one is also something you can analyze, you can understand. This also take consideration, of course, in the rate that we showed before. And this is how you, for example, you are making the very basic PyLint usage. Okay, so for example, here you can find in the documentation, this is just PyLint documentation website. I'm sharing it in the chat here. Oh, I saw that there are some messages on the chat.
It's mostly discussion.
Got it. Okay, so just to make sure that I don't need to keep my eye.
If there's anything important, you can jump in. But before you run away, if you stop now for a second, you mentioned before, sure, the dry principle. Do not repeat yourself. So people call it the dry principle. But dry, by the way, right, someone created the wet principle as a wet stands to write everything twice. So it's like it's kind of a joke. You can look it up in Wikipedia. But you mentioned the dry principle. Will you show us later how if PyLint can handle it?
Yeah, sure. So I'll get to that soon. I didn't write I write something which is a bit, do not check for duplication, but check that you use a framework. I'll show that custom rule later, but PyLint, okay, so that's a, let me just follow my track. We'll get to that later, right?
I apologize.
Cool.
Go ahead. Sorry.
Cool. Okay, so now we know how to run PyLint. Let's talk about how PyLint check looks like. Okay, so PyLint check is actually, oh, I miss my VS Code. Okay, cool. So PyLint check actually is one of three types. Okay, I'll try. Okay. So if we want to write a PyLint custom check, go to the documentation, just a second. Come on. Okay, here, hard to write the check. Okay, so PyLint actually, every checker is actually a class. This class you can, after register it to a PyLint run or just test it itself. And this class has one of three types of checkers. And now let's dive a bit into the world of static analysis. So every code file, let's start with every code row. Okay, so every code, even expression, is a text, is a string. The simplest way, which is not the more effective way to test that string, is use some string utils. So for example, I can check that all of my strings except of class names are in snake case, and that class name, every word that came after the word class is in a camel case. Okay, and for this thing, we can use the row checker, which is the most simplest way to write a checker. How a row checker looks like, for example, let me show you one that I created. So if we look here, for example, I created a checker that check the don't repeat yourself. We'll talk about it later. But a row checker is actually a class that implementing the base row file checker and implement one function. This function is a process module. And this module is actually every particular Python module in your software. And this module is actually represented here as a stream, which is a stream of course, text. Each stream we can loop on the lines, we can loop on the string, we can break the line and use string utils to check what happened here. Okay, so this is an example on how looks like a row checker on PyLint. Soon, of course, I'll explain everything that happened here in the custom checker, but just to make sure, we are implementing the base row file checker and the function process module, which get the stream of the file as a row text. Again, this method can consider as simple, but is not that efficient because running on a text and especially do correlation between lines, between variables, etc. in the code is hard. The second one is token checker. What is token checker? So if we think about a code file, and this is maybe let's start here in explaining because that's a very simple case. So back a second for the example of the row checkers. Row checkers, for example, we have a class test, we have then a line test case, we have then a line definition text test log, and pass. Okay, so we can again do some string. What is token? So token assume that every code has some tokenization around the text that writes the code. So as you can see here, the representation of tokens for the class, for the module that you saw before, is, for example, start with the encoding, which is very important, and then we have a name, which the value is class, and then a name, the value, and then the operator, semicolon, new line, which is also considered as a token, and then indentation, which is very important in Python, etc., etc. Now, this one is very helpful when we are trying to understand the big picture of a Python file, of a piece of code, without worry too much on what happened in that code. For example, where we want to use this one is, for example, when we trying to check two new lines in the end of file. Or if you want to check that there is always two lines between definition, we can simply run on the map of the tokens of the file and make sure that there is only one new line between indentation in function, only one new line between function name, which operator, semicolon, and indent and function body. Or, for example, we want to make sure that there is a new line in the end of a file. right? So here we can see that there is only one new line. We may consider to want to have two new lines, and then it's very easy for us to look at the tokens and create rule based on that, how it's looked from the code perspective. So if we look on a checker that's based on token, we have this one, for example. We need to implement the class-based token checker, right? And then we have process token, which is again the function we need to implement. And we get like the list of the tokens. And this list of the token, this is actually the table that I printed here, is exactly the same structure of what we'll get here in token. We can run on the token. Of course, the code here is not the most efficient code to run. You can create much better representation of token calculations and token manipulations, etc. But this is the second option, which is considered in the middle. It's simple to write, but again, not the best in performance. Or with run, think about it that your code module can be like thousands of files or hundreds of files, and you want things that run light and efficient. The last one, which is the one I most like, but it can be considered as a bit complex, is AST checker. So what is AST? I mean, just a short break into AST. AST is abstract source tree, which is like a tree that represents our software. So every software, when the interpreter takes it, when the compiler takes it, is first trying to understand how the software looks like, right? So this tree is a more efficient way to run over code and get an understanding how we analyze that, how we static analyze that, and creating, custom checkers and stuff like that. And here, let's dive a bit into some tools that PyLint created to support better AST. So Python itself has, in core Python, there is a package called AST, of course, which is a package that gives you the option to get the AST model, the AST structure of your code, of your Python module. PyLint creates on top of the AST implementation called Asteroid. What is Asteroid? Asteroid is like a AST, but on steroids, right? So this is where the Asteroid is from. It creates a lot of interfaces and help functions on top of Asteroid to give you a very easy way to do something. Let's back in our same fashion of showing custom rule. Here is a custom rule, which is the token. Let's find the redundant class checker. So the base PyLint checker, of course, to implement is the base checker, which is the Asteroid checker, the AST checker. And there are many functions that Asteroid create for tree operations. So how we said our code is a tree, and soon we'll see another tool that PyLint gives us for analyzing those trees. And here I use one of these functions. This function is live class definition, right? So PyLint, of course, will model our static tree of the software, and then every time we are leaving, meaning we are getting to the last leaf of a class definition, we can have something. We can have some operation on this part of the tree. Now, tree is a very good data structure. It's very easy, not easy, but Asteroid make it easy to do some operation manipulation on it. And I'll not go over all the Asteroid functions that we do have for nodes, etc. You can, if you want or need, write custom checks, just go in and get some understanding how Asteroid is on top of the AST built-in modules. Let's just think, for example, many node functions, right? And many return and visit and leaving functions. So think about it that every node has steps, as the step of starting, as the step of visiting, and as the step of leaving. So if you think about some custom check, and soon we'll go to, trying to model our custom check, or at least look at what I already write, just think of the node and think where is the best place you will want to get involved in how the module looks like. Now let's look at PyReverse. Okay, so we do have some vision where and how we should write a custom check, but we don't know how our code looks like. Let's take an example. We have a framework, which is a big framework, or we have a library. And we want to create a set of checkers, particular for our library, but we are not the only guy who wrote this library. So we want to check what happened there. So there is a very nice tool called PyReverse, which is also from the set of the PyLint. And this tool is actually building a graphical representation of the tree of our software, right? So let's see how it looks like. So PyReverse and Asteroid, all of that, even the CLI interface is installed together with PyLint. And now my code is not too much, but let's go to some of the library in my virtual environment. Let's, for example, look on, I don't know, maybe, let's look, for example, on the request library, okay, which you all know. If I run the PyReverse here, it will create me a dot file. What is a dot file? Dot file is like a diagramming language, okay, to diagram stuff. And if I'll create this dot file, okay, PyLint will create me, the PyReverse will create me a graphic representation of how my library look like. Okay, so we can see the package starts with request. And it also has another package, request certificates, request help, and request packages, right? If you know request, you know this is like the other. And then we have the API package, which is also part of the request. And from API, there is nothing because API is public. Okay, this is something easy to understand. And then we can see, okay, API is something that is not some deep inside the package. We can do some operation. But status code, as you can see, has many relations with other part of the tree. And we need to think about a maybe different way how to analyze it from the Asteroid. So again, PyReverse give us a very nice, it can be complex like here, but it gives us a very nice representation of our a code or package or module. It also creates a preview for the class diagram of our library, which here again, request is a very big library, but we can see, for example, the response object, the adapter, a very powerful tool. When you want, not even for PyLint itself, maybe I can think some more creative way to do that. If you want, for example, create some remediation for our checker, auto fixes, we can, for example, show the people, look at the diagram and understand why your correlation between classes or dependency are not make sense, and make it visualize with PyReverse, but it will also help you to create custom checkers. Okay, so now that we understand that the last tool that I didn't thought to mention, but since Jacob, you asked, one of the nice tools that PyLint has I'm trying to find it. Yeah, so PyLint also has a tool called Similar, which is actually gives score to all the similar, as the name mentioned, to all similar code in your Python database, and finding you duplicate code. Now, this duplicate code can even have different variables, names, etc. But PyLint, again, using the AST, so it have the static similarity of duplications. As you can see here, you run PyLint, and then it says you have some duplicates for get value and set value, etc. Okay, so Similar is another tool came with PyLint, and since we already start to mention, there is another tool called PyLint, which help with Emacs, give your developers better tools. If we're back here, that's a point that I forgot to mention again, and I mentioned it partially, but there are many tools for static checks in Python. I like PyLint because it's not that simple and give a very easy way to create custom rules. But you have tools for security, as I mentioned, Flake8, which is the simplest one for typing checks, etc. Here, this is just the main GitHub PyLint page. You can just go there and find whatever you want. Okay, so now as we understand what we want to create, let's look how the custom checkers looks like. So here I create 4 custom checkers, and I'll explain what each one of do, which is usually a very particular way for a organization usage. So you can see here the name. I'm not getting too much, but for example, here we can see that we have this pattern of repeat yourself. Now, why? Sorry. Yeah, we want all our HTTP calls get into dedicated client. Now, the reason for that can be many reasons. We can think about security reason. Always to attach headers to our HTTP calls. We can think about it as duplication. I mean, now it's very simple. It's a very simple example of HTTP client, but HTTP client, as you may know, can go to a very large, complex structure. And we want to keep all the people to use the same HTTP client that we have. So what we check here is that we're not checking for duplication. I am checking that every HTTP call made by the HTTP client. And how do I check it? I'm checking that no one in our code base is not using the raw HTTP call function. So as you can see here, I have a special warning that the request library should not be used. Use HTTP client wrapper instead. Okay, this is actually came from my custom rules, and we look on it soon. But this is for your question, Jacob. Not always duplication is something you want to avoid by detecting duplication. Sometimes you want to avoid and help developers understand what to do. So this example, I want to avoid duplication, but instead of that, I recommend all users, or I enforce all users to use one unified HTTP client, right? How this HTTP checker looks like. So now we'll go row by row to see what happens. So as I said, I have the class. I'm implementing the raw file checker. I'm not saying that the right way to write this custom checker. By the way, is this font size is fine, or it should go bigger?
You're good enough. Go ahead.
Great. Okay, so the thing that we need, which is the fundamental for every custom checker or every checker, is the name and the message, right? So we need a unique name for our checker, which is the we'll use for the plugin. When we want to register that, when we want to run that, we will need a unique name, and this unique name should be in PyLint too. So before you decide the name, you should go to PyLint and check if there is not already built-in a checker with this name. And then we need to configure the message. Message has, of course, the text message. This is exactly what we saw there. Okay, so here we can see the comment, which is the exact what we see here. And we have the message code, and we have like guidelines. Okay, so these 3 parameters is combining a message. Here is also the message symbol. And if we go back to PyLint documentation, we can see on the message overview that each one of the, I don't know why it's so slow, but we can see the E is error, and we have the refactor, and we have a different code for every kind of a PyLint message. And we'll need, of course, to assign the right letter for the message you want to represent, and also a unique ID. In our architecture, I decided to start from something, for example, 2400, and go up. It's up to you, to decide this number, but try to keep this convention. Now we get to the most interesting part, the checker itself.
Does PyLint check that you are not taking code that exists already?
Sorry?
Can you override the PyLint? Like PyLint has a warning.
No,
Let's
so
say
if you run two, it will fail the test. So if PyLint found two messages with the same ID, it will fail the test. What you can do in this case is exclude this test, with the PyLint RC or just in the command line, and then this test will not run and this message will not exist. And then you can use the same message if that's work better. Okay, so here we have the process module function. And here, as you can see, we got the code itself, okay, the stream. So first, I want to say if this is the HTTP client, which is the only where I'm allowing our user to write calls to request, I'm return. I don't want to run on that file, right? And then I start and run on the code. And then I ask if I found some of the request libraries, request or URL lib3 in the row, and there is import term in this row, which is import from, I want to return the message. Okay, so I'm adding the message. Again, this is not the efficient way. This is not the right way to write this checker. The best way to write this checker is, of course, running on the AST and visit all the imports, okay, which is a function on Asteroid. But just for the example, I ran on the file, I checked the string. If I found a row that import with some of the terms, one of the request library, I'm adding the message. All right, so this is the row checker. Now let's go to the token checker. Okay, so for example, I used to, we do have many developers which writing Python was their first job. And one of the patterns of a new developers is write what's called the golden hammer. They know one tool of the programming language and they use that again and again. Now here, for example, they use a lot of ifs to do something. And we may know that there is a better way to do that. We don't want to write very long if loops. We want, for example, to use loops on the argument. We may want, to use switch case, which is what I recommended here. And we want to analyze those long lists of ifs. And if their condition are the same, we want to show this warning. Okay, so we can see this one here. Multiple if statement with the same action, which is the same left-hand side, condition found, replace it with match case statement. Okay, so this is our custom check for the golden hammer pattern. And this one built with token, let's see how it looks like. So again, as I said, there is of course message and the name, and then there is the function of process tokens, right? And here we got the array of the token. And for every token, we need to check the if. And inside the if, we have a function that check if the left-hand side, right? If the left-hand side of this if, what is the left-hand side? And we built an array of all the left-hand side for particular if. How it looks like, so here is another loop on the tokens, and I check if the type is name and not operator, which means it's if, and then if it's not the right-hand side, okay, so I'm appending the string, what is that string? This string is actually the left-hand side. Okay, so this logic helped me to find all the left-hand side in consequence if statements. Now again, I can of course use some Asteroid. I just want to demonstrate the way to use tokens. I'm pretty sure you can find a much better and efficient way to do it with AST. But just for the demo, after we get this array of left-hand sides of the if, we can add the message. Now we can do even a better thing. So the message is actually support formatting. we can pass parameters into the message we are showing. And this is exactly what I'm seeing here. So if you remember what we did have in the message here, you can see this action, right? The same action. This is the left-hand side that our user repeated again and again, right? So I pass the relevant left-hand side and help more to understand the message. So message can be also dynamic. We didn't have too much time, so let's go now for one of the for the base checker, for the AST checker. So here I want, we have many developers which never use Python. They came from a object-oriented programming languages, and they like to write classes. Now, we know in Python, not everything's supposed to be class. Even, you know, I work in an organization, dev organization that create a lot of microservices in Python, and we run serverless. Actually, our only class are to represent models. Everything else is a function, and that's important because we don't want to keep state. We don't want to trust the state of the classes. So I want to tell my users that class should be a class only if it has init function, right? If it has init function, that means this class is something, right? So let's say, for example, if I created an init function, we'll see that we are getting now we are getting, we don't getting the comment on the class itself, but we can see here that the user tried to treat us because he created an empty init function, and I have another check, and this check tells him no self-assignment in the constructor. And if there is no self-assignment, there is no reason to write this init function. And if there is no reason to write this init function, maybe that's supposed to be not a class, but a function. Right, let's try to write some function here, self-name equal Gabriel, and then we'll not have this error anymore, right? So this must be a class. Now let's look like how I implement this custom check. So if we'll go here to the redundant class checker, we do have here two messages, because as you remember, we do multiple checks for these checkers. So I do have two checkers. I can also assign a different code to a different message. I didn't do that here, but if we, for example, trying to have a journey for custom checker, we can say you have the main, which is error, but then we lower the rate of the error messages into refactor messages and stuff like that. Now I use, for example, the function leave plus def, and as I said, there are many Asteroid helper functions that helping you to visit the particular cases of your code. I decided to go in the leave class def, which means the end of the tree of the class definition. So for every end of the tree of class definition in my code package, we will run this checker. Okay, we will run this function. The first thing I want to check if this node is implement something. If this node is implement or inherit another class, I don't want to throw this message because this is the reason use the class, is try to inherit or implement something. And then I check if there is construction. So every, as I said, the class definition will give me the node, the exact node we are now. And this node is the class because we are leaving the class. We know everything of the class. We can check the method. Okay, so and this is, as you can see here, is a much faster and efficient than I need to go and tokenize all the classes in a text file. It's just a tree. And I have here a generator function to loop over all the method. And I check if there is init in the name of one of the method of the class. I am, if there is no construction, I'm adding the message. Fine. So now if I don't have init, I'll not get into the message and I'll not return. So I also check if there is inside the init another function of self. So I'm getting to the local attribute of init And this is also an AST node, so I can continue to run in the efficient functions that allows me to run on the node. And I said, if inside this function, one of the nodes is assign attribute and continue the expression of self, okay? So if not, I'm adding the message telling you that init function, constructor function must include a self. Okay, so this is the way to use, for example, the asteroid to run over class method and over class method and then over the init function node and adding these messages. Okay, so this is actually the three-way to run or to create PyLint checker. I hope that I give you, some ideas how to write yourself, how to think of a new checker and decide which one to want. That will be a nice game, if someone has an idea, just discuss about it, but I'll just some last words. Now we created checks, right? And we want to add it to our code base or to our software development lifecycle. So the first thing to do is to register our custom checker. Register is actually a function of PyLint that assigns the new checker as a plugin to our PyLint. Now there is two strategies where you keep your custom checker. We actually have custom checker for every microservice and also another repo for centralized. So the particular service is already configured as I saw in pre-commit hook. So everything particular for a service is running for every pre-hook. And we also have in our GitHub actions where we run a Docker that run PyLint, okay, when we run action that run PyLint, we also clone the centralized PyLint checker that custom to our organization. And this is, we are not running locally, but we are failing PRs if something from our centralized custom PyLint checker fails. Okay, so this is the way you can, you can do it in a centralized repo and then you need to clone it somehow. And a different option is, of course, keep it on some library on the code itself, and then create pre-commit hooks and tell PyLint when you run on the folder, always check if there is, for example, PyLint checkers folder and add it as a plugin to the PyLint run. So this is the way, to do continuously improvement with the custom PyLint checker. I think I'm done. Let's go to the.
Oh yeah, you showed us a lot.
Yeah. Great. And it's actually exactly. Let me do the calculation. 8 p.m.
Yeah, it's 4 a.m. in your time.
4 a.m. Correct. So we exact on time, which is great. And yeah. So thank you. I inviting you to my LinkedIn or Twitter. I'm trying to write, especially on DevSecOps static analysis. This is the most thing that I'm doing lately. So that interests you, let's connect there. Yeah, so thank you. Now let's jump to the fascinating discussion.
Before we run discussion, any specific questions to what we were shown? You showed us a lot. You showed us much more. I didn't know PyLint was so rich, I must tell you. I thought it was like one command line that you run and it tells you also things in PyCharm or whatever. But apparently it's much, much richer, and thank you for showing us that. But does anyone have questions? And we do have many beginners, so be...
Sure, I'll try my best.
Yeah, try to be gentle to them. They may not be, some of the people here may want to know, but it's sometimes even hard to ask the questions for them. So can you, some of you have any questions? You already answered my question with the dry principle. You actually showed how this can be done using some tools, but while others are thinking about questions, let me ask you another question. So how much do you really customize PyLint? I know it's pretty good from the beginning because PyCharm uses it, but and it helps me a lot of my coding. But how much do you really need to customize if you're an organization? How much effort a big organization usually puts into this?
So actually, that's depend, in the real needs. So for example, and I remember that that was part of my talk in PyCon in Israel. We did have a code base of 4,000 test cases that used to fail every night. 30% of the tests used to fail. And the reason for that was, the different level of developers that wrote code that sometimes, go to external interface, etc. The customization, we did have a project like 3-month, 5-person team that create custom rules, because that was the only way we are creating a balancing way to deliver a new test to this code base and to not continue, to fail 30% of the test every day. For example, for the custom security in JIT, we do have custom rules only in one microservice, which is very critical RBAC service. Okay, so that's very depend on the way you think of. I think the place that I can say generally you will want to invest that much in creating custom rules is in a very big organization that people who are not excel in Python contributing a lot of code.
Okay, so you said it's a 3-month project. It's like this is because you.
No, but we wrote like first we wrote a framework. Okay, so we took all the failures from what we saw in the failed test. We took all the failures. We normalized the bad code that occurred then. We create a framework, internal framework that avoid people do the same mistake. And then on top of that framework, we create like dozens custom rules. Okay, so that's work wasn't only the effort of writing the custom rule, but writing the framework that avoid people from contributing bad code.
So okay, so you did extensive, but you're a security company in a sense because you're trying to offer those capabilities to others. So it's understandable that you're using a lot of it, but if someone does this internally and they are not a security company,
let's. I'll take some wider zoom on that, and let's have some roles on static analysis in general. Okay, so one of the places we saw a lot of custom using in static analysis now is in infrastructure as code. So, for example, organizations today have repositories with thousands lines of infrastructure configuration, Terraform, cloud native YAMLs, Helm charts, etc. And this is where a lot of organizations trying to have a model of permission who can, for example, contribute code that create resources, who can, for example, update resources, and who can, for example, deploy resources. And for this particular case, many organizations that we working with and even do it ourselves, writing, there are some models of writing infrastructure as code static analysis. One is use OPA, which is Open Policy Agent, which has a model of static analysis for the particular case of understanding permission, and also use SemGrep that support many of these configuration, and writing custom check for building a permission model for our infrastructure as code. Another place that I saw many customization, again, which is not consumed that much, is when you have a framework or a library that you want people to work as you plan that they will work. If we look, for example, on the JavaScript ecosystem, almost every JavaScript library today, JavaScript front-end library, has its own set of linter tools, of static analysis tools to make sure. So, for example, React has some, Angular has some, Vue has some. Every front-end library, a big front-end library, front-end framework, implement the custom rules so people can make sure they're writing in the way the maintainer or the creator plan to do that. So I think that, to back to your question, if you do have in your organization framework that you see many bugs that repeat themselves, that people don't want to implement, this is where I would jump in and create custom rules that make people write the code in the way you plan they will do that.
Okay. Thank you. There's another question here, which was in the chat. So Pratpool is asking, what's the best way to get started with PyLint for a novice? And remember, some of the people here are quite novices. We have some experts, but we also have like newcomers to Python here. So please help us.
Yeah, so the first thing, is to run the built-in checker. So if we look on PyLint, we can see there are many, many built-in checker in the libraries. Okay, let's look, for example, the messages here. PyLint include, I think, more than 100 checks. Just dive into one of those checks and understand how it works. Okay, just pick one, whatever it is, a message import error, for example. Okay, and enable to import something. And this one is very easy to reproduce. So just pip install PyLint, try to make this error happen and understand how you write better code that fixing that. And then you can also contribute the import checker. Okay, this checker is open source on GitHub, open source that you can clone it, you can, go to GitHub and try to do something with that. For novices, just something not related to Python, related more to open source. Now GitHub enable code spaces, and this is a very, very cool that you can go to almost every open source library, dive into that. I mean, I think that this is one of the practices that I always trying to, get into juniors. Open source is here. Everything is on GitHub. Just go there, read the code. The code is written. Someone already write the code. I can say that when I was junior, I used to work as a freelance, and for every project came, I checked on the internet if someone already created, and then I accept that project. I said, if someone does that, I can do that too. And this is very cool in open source. You can go there and you can just check the code, just check what happened there. And PyLint has a very good comments too that explaining everything. And why I mentioned code spaces, because now, for example, if you have this library, you can fork it. Okay, and now there is the functionality of the dot. So I'm not just now clicking the dot sign on my keyboard, and GitHub is actually opening me an environment of the forked PyLint repository that I created, okay, in Visual Studio Code, and you can just play here, and you can install extension on the browser, on your code space, and you can run the debug here. You can do everything here, which is a very, very, efficient way to learn some open source and how things work and how you can start with that.
Gabriel, before you run away, I know it's late, but please, one more question. Nick is asking, sure. Is it ever an issue that your AST custom rules need to be changed when changing/upgrading a Python version? How much the AST actually does change between versions?
So actually, between 2 to 3, there was a big change, but that happened for every Python code base. We didn't. I mean, I'm trying to remember. We are running on Lambda, and I think I don't remember that there was like version collision between PyLint. No, I didn't. I don't remember that we have a case like that.
Okay, so the AST will be the AST tool will work nicely if you're at Python 3 and up, and without much change. This is what you're suggesting.
Yeah.
Okay. Any more questions? Yeah, Nick says thank you. You can check it on chat.
Sure. Yeah, now I'm seeing the chat.
Yeah. Anyone else has any more questions? Questions going once? Question going twice. Questions going 3 times. Well, oh, someone jumped in. No, they say thank you. So actually, that's the time to say thank you. Don't go away. We're sticking around, but I want to make some noise, make some features running on the screen or whatever. Gabriel, thank you very much.
Thank you. Sure. Thank you. Keep in touch, and any question, I'm just around on the internet. You can find me, and I'll be happy to help. Thank you.
Okay. Thank you all. Don't go away. We're still here. We're just finishing the